invite Mr. Kinkan Namki on stage as the moderator for the last session. Thank you.
Respected Dashos, distinguished dignitaries, friends and students from the college. A very good afternoon. I think the last session of the day is always the toughest. I can already see the fatigue on your faces. But nevertheless, there's always a but. Last but not the least, we have 4 dynamic and very young presenters touching varied topics. We will be touching construction equipment. We will be talking about variation in hydropower construction tunneling. We will be talking about indigenous home design and the testing facilities available. And we will be talking on bridges also. So looking at the contents, I think this is the session where we will be talking on a varied topics. Due to time constraint, I will not introduce my speakers, as the speakers' profile is already available in the program schedule, which I'm sure you all must be having. One thing I want to request my speakers, we are already running behind schedule. Unlike my predecessor, I'm not liberal at all. Let us be very strict to the time. Each one of you have 15 minutes. 10 minutes there will be a buzzer, mind you. At the dot of 15 minutes, you have slightly cut. Let us stick to the time, because after that then we can go for discussions. So without much ado, I think can I invite my first presenter is Mr. Is Mr. Thinley Pelzang. He will be talking on the installation of electrical equipment, management and challenges in tunnel construction. Whenever we talk about tunneling, we always think only about civil engineers. Yes, civil engineers very important. But without equipment, without motors, without generators, without compressors, civil engineers will be handicapped. So they need a support. And management of this construction equipment are very important. You may have all the resources mobilized, you may have all the manpower, but if your equipment fails, those days where we do dealing with hand are gone. We do dealing with boomers, we do dealing with sophisticated equipment. So how to manage the construction equipment, Mr. Thinley Pelzang will touch on this one. Mr. Thinley, you have your time now, please.
Good afternoon to all. Thank you, Mr. Moderator. As earlier presenters presented on construction of metro railway tunnels using TBM, dam foundation, excavation of surge shaft, HRT tunnels and pressure shafts. So what enhances the construction work? I would say it is the construction plants and equipment that assist them that helps to progress the construction work. So I will be presenting a case study on installation of electrical equipment, management and challenges in tunnel construction. This is outline of my presentation: introduction, construction methodology, equipment automation, power distribution system, equipment management, challenges and conclusion. Construction equipment plays a significant role in the building process for a construction industry. With its utilization, extensive volume of work can be completed in a shorter period of time. So most equipment use a merger of diesel engine with electric drives. Construction underground tunnel being a confined space, this type of equipment has more advantages due to less exhaust emission, which translates to fuel saving and longer engine life. One of the factors that delays project time is equipment failure due to uncertain breakdowns. So equipment failure causing delays and huge cost to the project can be achieved through proper equipment maintenance strategy. I will be focusing more on this. This is the scope of work and current status of EDIT 4. Construction methodology. Tunnel excavation is done by conventional tunneling method, that is a drill and blast method. It is a cyclic processes of following activities. Firstly, surveying and profiling, drilling, then loading, charging and blasting, then defuming, that's a ventilation system. Then comes marking and scaling, geological mapping, then rock support as per the rock classification. Different equipment are used for the above cyclic processes, like providing rock support as per the rock classification. Then this providing with this rock support is generally for safety of the equipment and the workers, and further advancement into the tunnel. Construction equipment enhances the progress, and minimizing the equipment breakdown is very important. So there are two areas to minimize the equipment downtime. That's equipment management in terms of maintenance to retain the condition of the equipment. Then one is power distribution system, that is to power all the electrical equipment and apparatus, and to prevent the motors failing prematurely due to low or high voltage. Before going to the management side, I will talk about equipment automation. Construction equipment are integrated with different control systems. Equipment maintenance and operation depends on how the teams, operators and the maintenance teams are diversified with the modern technology. So definition of equipment automation is a process having combination of various systems requiring minimum human assistance in an automated system. The desired output is based on the linking of inputs with the respective states of the system. So the components of automation are sensors, like we have proximity sensors to detect the system states, then actuators like cylinders, motors to output the command, and controllers like PLC, SCADA, DCS systems for the program flow and the decision making. This is the electrical automation of batching plant. This is where the cement mortar is mixed. So if we look at here, the compressed air pressure will actuate that one is a cement hopper, actuate the closing and opening of the cement hopper depending upon the input commands. So the cement hopper gate has sensors installed there. It will send the open or close feedback to the programmer. Then the cement hopper has a load cell installed in it. It will display the quantity of weight measured. So all these programs are controlled by the controller, PLC, and we have a SCADA system. This is a weight shortcut machine. It is operated using a wireless remote controller. This is a sack loader. We call it a continuous loader, used to remove the blasted marks. These are all automated system. So it is run by engine. All the works are done using an electric supply. This is Sandvik Till Jumbo TT820, used for rock bolting, paste drilling, and so on. Power distribution system. This is also important part. It is a transfer of electric power from step-down substation to the end user or a consumer. So equipment such as transformers, breakers, and other protective devices are installed. And diesel generator set is also installed for backup plants during power outages. So this is the power distribution system of ADIT-4. We have a 750 kVA transformer distributing the power. Then we have a 650 kVA DG set, which is synchronized with the system through a manual changeover switch. Then down there are so many loads distributed, so many connected loads. So coming to the right side is underground voltage regulation. It is with the increase in tunnel length, there is a huge voltage drop. So we are not able to operate the electric motors. So in order to operate the electric motors, we have to maintain a permissible voltage range. So what we do here is, at the first there is one transformer. It steps up voltage from 415 volt to 11 kilovolt. So it is taken inside the tunnel, and then it is again step down. So this is here we use offload tape changer as a means to regulate the voltage. Maintaining the voltage is also very important because a motor may prematurely fail due to low voltage, and sometimes it fails because of high voltage also. This is a 500 kVA transformer installed outside the portal to step up 415 volt to 11 kilovolt. Now coming to equipment management. Equipment management in terms of maintenance plays a vital role in retaining the condition of the equipment. Equipment are expensive and involves various complexity in terms of operation, control, and maintenance. Major equipment used are, we have drill jumbo, ventilation system, egg loader and dumper, shortcut machine, patching plant, concrete pump, and dewatering pump. Usually there are many types of maintenance. I have classified under three that are commonly practiced at the site. Firstly is periodic maintenance, then preventive, then breakdown. This maintenance works are carried out to prevent the equipment from failing. First one is periodic maintenance. It is a time-based maintenance carried out regularly according to determined schedule. Maintenance tasks carried out to reduce the likelihood of breakdowns. It usually involves inspection of external and internal parts and timely change of lubricants, engine oil, etc. This is an example of periodic, like checking of oil level, coolant level, fuel level, engine oil, then change of hydraulic oil. Then with this we change oil filters. Next one is preventive maintenance. It is a fundamental plant maintenance activity designed to improve equipment life and avoid any unplanned maintenance activity. It's a regular maintenance carried out as per planned schedule. Maintenance can be done weekly, monthly, quarterly, and annually. The key to all good maintenance is inspection. Inspection is very important. Sometimes due to vibration, due to movement, there will be loose connection, the nut bolts will be loose. So inspection is very important. So this is preventive maintenance schedule. So I have written about shortcut and batching plant. So usually electrical equipment does not fail. It's a more reliable. Electric equipment are more reliable, very easy, more reliable and requires less maintenance. So these are the basic maintenance we have to do. Is terminal tightness checking and cleaning of these electric panels, then checking of motors, pumps, and greasing if required. Then for shortcut machine, we have to clean this remote controller. It is a wireless remote controller, and we have to clean it timely. Then overall cleaning. For batching plant is almost same. So breakdown maintenance. This is common in every project. It is performed after failing parts or components of the equipment. It's a very expensive type of maintenance due to downtime. So until and unless you replace that part or you rectify, your machine will be, your site will be idle. So some of the equipment breakdowns recorded at the site are, so number one is a major breakdown, is a failure of shortcut machine remote controller. So without remote controller, we cannot do anything. So it's all controlled by remote controller. So this lasted about 2 months. So because we are new to the tunnel construction and we never knew that we have to keep spare parts. So it lasted for a long duration. Second one is a batching plant. This is a slack steel fault. This is a simple minor fault. It is a minor fault, but it depends on how experienced the operator and the technicians are. So that one is the air compressor starting problem. So for that there was a small loose connection. So it is important that it is important that periodically we need to do the maintenance, like as I said earlier, like tightness checking and cleaning. So that one is modification of starter discs. So this is required sometimes as per the site situation. Now the challenges. Apart from Miramari drip project, CDCL is executing HRT excavation for the first time. So for this new project, new sets of equipment and manpower were deployed. So there are numerous challenges that were faced by the team in operation, control and maintenance of this equipment. So first challenges is competency of operators. Operators has important role in maintaining the equipment. So skillful operation controls the equipment cost by reducing the maintenance. Then quality output can be achieved through experienced operators. Then operation error is the second most cause of downtime after hardware failure. The next is problem solving skills. This refers to maintenance team. Since all are new to the equipment and it requires much experience to attend the breakdowns. So problems associated with the circuits are complex. It requires much time to rectify. Identifying the nature of fault and solving them through innovation and modification are difficult. So one of the most challenges that we electrical or auto face is locating the fault. It takes more time than solving. Third one is trainings and empowering the employees. Due to new set of equipment, operation and maintenance is difficult. So therefore we can conduct relevant trainings to develop the skills and knowledge for better equipment management. Fourth one is supply of materials and spare parts. This sometimes we do not receive on time. And fifth one is maintenance cost. Maintenance cost is there is a very high maintenance cost for this equipment because whenever there is a breakdown, the parts are very expensive and there are frequent breakdown there is a leakage from hydraulic hose pipes and every day we have to attend that maintenance. So in the conclusion, the common problem in every construction project is delay.
Please be fast.
Delay in construction is the slipping over plan schedule. Most of the delays can be reduced by proper equipment management. Successful accomplishment of construction projects in terms of profitability, quality and timely completion can be achieved through proper maintenance management strategies. Thank you.
Okay, Tinle, thank you so much. I think that was tolerable. For any project, I think the main aim is to complete the project on time, as per design and within the budget available. Now, one of the main reasons why projects gets off-road, off-track is because of delays mainly attributable to equipment. As you are seeing now, the main thrust is to reduce the downtime of the equipment. For that, inventory management is very much important, as you were saying, spare part inventory management. And number two, he was talking about three types of maintenance: time-based, preventive, and breakdown. Breakdown maintenance is the least we want to have, but I suggest we should have, rather than preventive or time-based, we should have condition-based maintenance. By looking at the condition of the equipment, if you can do the maintenance, that will resolve a lot of downtime, unnecessary stopping of the machines, unnecessary spare part replacement. So, inventory management and next step of maintenance should be condition-based maintenance. That I would suggest floor to keep in mind. And okay, in view of the time, I will now present my next presenter, Mr. Karma Gelle. He will be talking on the variations. Because whenever you talk about a tunnel, one thing we come in mind is variations. More than 100% variations. Now, and for that, what is most important is identification of the rock classification. And Mr. Karma will be giving us a case study on a particular work that the CDC has done. So, Mr. Karma, I think your time starts now.
Thank you. Guest from abroad, Dasho, my senior colleagues and dear student, very good afternoon. I hope it's not evening. My paper is based on the experiences in the construction of tunnel in Mangdechu Hydroelectric Project Authority, Mangdechu Hydroelectric Project. So it is basically the data analysis, and you will see more of text and figure. So I hope you will not get bored. If you see the payment in the construction of a tunnel at present generally is made in the volume of rock excavated, and then the rock supports separately, and we have no way of knowing how much per running meter of a tunnel will cost you. But the trend is catching up now. If you see, there is a tendency to invite the bids for tunnel construction in running meter. We have started this from Dagachu project, and then this is being also practiced in Nikachu project. So my paper tries to see what will be the cost. Try to examine what will be the cost of tunnel excavation per running meter for different sizes of tunnels, and then different rock masses, rock classes, and how this unit cost of tunnel excavation varies from one rock classes to another, and also from one diameter to another. So this will be sort of handy information for the practicing engineers later. So the data I have used in this in my studies include a wide range of tunnels, starting from 3 meter diameter for drainage gallery to up to 9 meter diameter for TRT. In total is 7.1 kilometers of tunnel, which is fairly good data for these studies. Now it is not only the rock classes and then diameters of the tunnel. Of course, these are technical parameters that will determine the cost of the tunnel excavation, but there are also many other factors which will determine this cost of the tunnel excavations. So under this assumption, which otherwise will influence the cost, so these are the factors which otherwise will influence the cost, but I have taken this as a constant parameters. So this includes the excavation method. Here is a conventional drill and blast method, which the previous speaker spoke. And then, of course, the base price of this your contract, base price for your contract value will also determine this the cost of this tunnel excavation. And then the hauling. Hauling means the removing of excavated mud from the tunnel. So generally in the tunnel excavation, the removing of excavated mud from the tunnel up to from the tunnel and beyond up to 1 kilometer beyond the portal is included in the tunnel excavation as a standard practice. But beyond 1 kilometer of portal, the carriage cost will substantially influence this excavation cost. That is why it is not built in the excavation. So this is paid separately. And then the working shifts in my study under consideration is 2 shifts for 24-hour cycle. 2 shifts is for 24-hour cycle. Normally 2 shifts is considered optimum, because if you increase the shift to 3, then your operational cost will increase. And if you reduce the shift to 1, then your fixed cost will increase. So the optimum is generally is 2 shifts. And then the hauling will also determine, the type of hauling will also determine the cost of the tunnel. So this hauling here is standard, this one using dumper and ordinary excavators. And then the type of rock support is a standard, which I'll come later. And then the rock mass classification, we have a different rock mass classification, but under this study, the consideration is RMM. And rock class 5 is not included in this study, because the rock support for rock class 5 is very much dependent on the adversity of geology. And then the increase in the rock support for rock class 5 from class 4 varies significantly. So to establish this one relationship is difficult. So that is why I have excluded this rock class 5. Just to give you some ideas for to those who are not in this underground activities and not this one in the geotechnical field. Basically, we have the different system of classifying the rock mass. Here in our project under consideration is a rock mass rating system invented by Venevsky. So this classification system categorizes the rock masses into 5 classes, and depending on the 6 major broad geotechnical parameters, this rating is given from minimum of 0 to maximum of 100. So at every 20 point interval, each rock class is classified and defined as rock class 1 as a very good, which is where the rating lies between 81 and 100, and rock class 2 is good, between the 80 and 61 rating, and rock class 3 is fair, then 4 is poor, and 5 is very poor. So it is almost like an adverse geology in the 5. So the typical support, why I'm putting this support, presenting the support, rock support here is the excavation cost of tunnel is constitute mainly 2 parts: the excavation of rock mass and then support system in the tunnel. So in the you have seen in the previous rock mass classification. So for rock class 1, the tunnel is generally unsupported, which means there is no support. So it is expected to withstand by itself. And but wherever there is required necessary, we call it spot bolting. You put it spot nailing. It's something like a random. And in class 2, it is also minimally supported, generally about spring level with the minimum shotcrete and the minimum rock bolt at a larger spacing than what is required. In the class 3, then the patron or systematic support system starts from class 3. Then you will have a patron systematic rock bolting, and the diameter and the length of the rock bolt is depending on this nature of the failure that you will foresee. But general typical design drawing given is 100 mm shotcrete all along this excavated profile, and then you have this patron bolting. And in the class 4, in addition to the support in the class 3, you also have a steel sets. We call it steel ribs. Is made of ice section in the tunnel profile, all using a lattice girdle constructed from this rebar. So these are the support system that we use in the tunnel, which will constitute part of this tunnel excavation cost. Now, as I said before, the general trend so far in hydropower construction in Bhutan, the excavation of tunnel is paid in the volume of rock excavated in cubic meter, and then rock supports separately in terms of kgs empty for steel set, shotcrete like in cubic meter, and then the rock pulls in running meter something. But with this mechanism of payment, we do not understand how much it will cost per running meter of tunnel. So in order to establish that one, so I have worked out per running meter of how much rock mass excavation is required to be done and how much support needs to be installed depending on design and drawing. And then worked out per running meter cost, applying these respective units rate for each of these different diameters of tunnel and each different rock classes. So if you see this highlighted portion in yellow, why I have highlighted is in Bhutan, we have the HRT, headrest tunnel, in the range of 4 to 7 meter at present. 4 meter for generally up to 100 megawatts, 130 megawatts, and up to 1000 megawatt. The HRT is 7 meter. This will help us to correlate our experience. So at November 2011 price level, why? Because this study is based on the contract contract of Mangdishu Hydroelectric Project, which is started towards the end of November. So if you just see, for instance, 4 meter diameter tunnel for class 1, it is 16,000. Class 2 almost 35,000, class 3 38,000, class 4 77,000, and I will just go down to this 7 meter diameter. For class 1 is almost 51,000, class 2 is 76,000, class 3 is 99,000, and class 4 is 160,000. It's all in this multum approach. And in order to understand at current price level what will be the unit this one unit cost of construction at present level. So this is the values. I have escalated to May 2019 price level based on the price adjustment formula given in the contract document of Mangdishu project itself. So at the current price level, the unit cost of excavation of tunnel works out to like this. For 4 meter diameter is 21,000 in the class 1, class 2 45, class 3 almost 50,000, and class 4 100,000. And for 7 meter diameter is 76,000, 99,000 in class 2, and 129,000 in class 3, and 208,000 in class 4. So now, in order to understand what the relationship this follows from one class to another and from one diameter to another, I tried to establish a trend, what trend it follows. So I plotted those figures in the graph to check the trend, what relationship trend this increase in cost from one rock class to another and from one diameter to another, what trend does it follow? So after checking for linear or exponential, logarithmic, different trend, so the best the best trend that suits this relationship is a polynomial trend. So you get this polynomial equation for this variation of costs against the different diameters for different classes of rock. So Y represents the cost per running meter of tunnel excavation. X represents the diameter, and then the legend you have this rock class 1, rock class 2, rock class 3. So again, then using this polynomial equation, I back calculated the cost per meter cost of excavation of tunnel for same diameter to check this correlation coefficient. What is the consistency? So I get almost the same value like in the analytical figures, and the correlation coefficient is more than 90%, which indicates that the polynomial trend actually exists for this variation of cost or unit cost of tunnel excavations for different change in diameter and then these rock classes. So Then with that figure, I did some cost ratio analysis to see how this changes from one rock class to another and from one diameter to another. If you see here, this slides indicate the cost ratios from one diameter to another. So for 4 meter diameter, the change in this one cost from 3 meter to 4 meter is almost 62%, and from 4 meter to 5 meter is 49%, and 5 to 6 meter is 40%. And if you see for this class 2, from 3 to 4 meters is 42%, from 4 to 5 is 35%, and 5 to 6 is 29%. But in the class 4, there is in fact in class 4 the increase in cost from one diameter to another is much lower than the other three. But in general, if you see here, the increase in cost from one diameter to another is decreasing with the increase in the size of the tunnel. And here, this cost ratio is how the cost changes from one rock class to another. So for 4 meter diameter, the increase from rock class 1 to 2 is 98%, and 2 to 3 is 27%, and 3 to 4 is 72%. But the general trend is the increase from rock class 1 to 2 and from 3 to 4 is much higher than the 2 to 3, which indicates that the variation in support from 2 to 3 is marginal comparing to other two. And the results and interpretation is that there does exist a strong correlation for variation of unit cost of tunnel excavation for change for different diameter and unit cost, which means some proportionality it exists. And then variation in cost from one diameter to another for each rock class follows a polynomial trend with the correlation coefficient of 90%. And then increase in unit cost for all rock classes depicts a decreasing trend with increase in diameter. And the increase in cost from, as I said before, 1 to 2 and from 3 to 4 is higher than from 2 to 3. If you see, for 1 to 2 varies from 40 to 66%, and from 2 to 3 is 30%, and from 3 to 4 is between 60 to 75%. The increase in cost from one diameter to another for all rock classes ranges from 20 to 40%. And the conclusion is, these are for just a general quick guide. You cannot use it for detailed estimate and then of course payment. But and this finding will be valid within the similar price range. But if you are working elsewhere, then this will change. Obviously, of course, if you have more data, obviously it will have to improve the accuracy. And then if we update this, the cost of the basic inputs, this polynomial equation will be still valid, and this cost ratio will also be valid. Thank you.
Thank you so much, Karma. I think you're just on time with the bonus. I think the topic that he has covered is very, very relevant, because I think in the tunneling, while we have a BOQ rate, but basically on interpretation of rock mass classification, lot has to do on this one. And this, I think, as far as my little knowledge knows, it's very depends upon interpretation. So I think as long as we can classify the rock marks correctly, there won't be any issues of escalations. But if we go wrong in classification, it can pose risks to the tunnel also. If the rock class is actually 3 and if you go for 2 support, then there may be a risk posed. But for a rock class 2, if you classify as 3, then there will be cost implications. So it's a very pertinent topic that Mr. Karma has presented. Thank you so much, Karma. Now to go with the third presentation, something to do with our traditional Bhutanese way of construction and their testing facilities that are available. Mr. Pema, I think, can I have you on the guys, please? Thank you, Pema. I think we can start now.
A very good afternoon, Kuzuzangpo. I'm Pema, and I always, if I get the opportunity to introduce myself, I say that I am a CAC graduate and I am alumni of College of Science and Technology. And when we first heard about this construction seminar being organized by CDCL in collaboration with CST, we were very much delighted to submit our manuscript on about construction management of test facility in Bhutan. The title of the presentation, as it says, it's construction management of test facility. So, but in general, through the next 15 minutes, we will embark on a journey, starting from understanding the traditional construction practices. Then, in line, we need to know the earthquake scenario for Bhutan. Then, the activities that we, the department, have taken in the last 1 decade. Then, through which I will share about the SUTRES project, because this facility is an outcome from SUTRES project. So if you see here, if you are always in Thimphu or Paro or Princeling, the structure that you see is a reinforced concrete member, and the engineers now, they always like to design structures using StatPros and all member. But when it comes, if you really look into the statistics as per NSP, a total of 66% of households, like they live in such traditional buildings, and out of that, if you then calculate, like 83% of households living in such structures belong to rural areas, and then when we break down the construction practices in Bhutan, we have 2 types. First is rammed construction, which is very predominant in the western region, Thimphu, Paro, Ha, Ansuna, Punakha desu. Then as you travel towards the center, then you tend to see stone masonry structures. And if you go to further east, it is the stone masonry structures, but it's always with mud mortar. So you need to learn about the soil mechanics. Soil, because from what I understand, most of the engineers here now, they are more into steel structures than concrete, because we have ice codes and everything. But for such structures, we don't have anything. So now let's see the earthquake scenario. Before, it was believed that Bhutan, the Himalayan region of Bhutan, it's a seismic gap. Why? Because we had no data. There was no data about huge earthquakes happening in Bhutan. But that was proved to be wrong after the finding of 1714 earthquake, which is a huge earthquake. Then after that, it is said that Bhutan is no more earthquake-free heaven. So we will experience earthquake when we don't know. And my colleagues from DGM, they're really working into this, understanding the seismology. And if you look back to 2009 earthquake, it's very interesting, because in the 2009 earthquake, most of our traditional structures which are made in stone masonries, they suffered. And as we are recovering from the 2009 earthquake, we had another earthquake, 2011 Sikkim earthquake. And that actually affected the rammed structures, as you can see. And then the people, the community started saying that our traditional homes are not safe. We don't want to build traditional structures. And when we say, no, you have to build because it's our tradition, they say, can you give us in writing scientific evidence, which is not possible. That's where we embarked our journey. So from the statistics, the 2009 earthquake affected like almost 5,000 rural homes. And 2011, it affected almost 7,000. And now, we are a very small country, but we have our own strengths. If you look at the strength, we have a very strong culture heritage. We have rich repository of traditional homes. Our traditional knowledge system is very strong. The craftsmen, like if you go to Zoda, Zopenlu, Joachin, they know everything. But what is our weakness? Documentation is very poor. Documentation works are very poor. And even when we started doing some scientific analysis, engineered analysis, we could not find any data how to start. And then when we wanted to embark on this journey, we didn't have the test facility, nor suitable equipments. Now, if we have all those facilities, then we could do something. That's where we built this examination facility. And I hear that CDCL started the journey in 2009, and I also shared the same thing. My research on traditional structures embarked after the 2009 earthquake. After that, the various departments and agencies, they started forming technical core group to study those things. And then the culture, they took lead in having an international conference. And then the earthquake 2011 happened. And then luckily, the culture department, we had good collaboration with Japanese Institute, the National Research Institute for Cultural Properties. And then we studied the chronology of traditional structures, how it evolved. Because there's always evolution. What you see right now, the traditional houses are not like that 100 years back. It's different. So if you want to read about that, we have a good journal in our office. Then 2014, as the time progresses, we had another project, PHRD, World Bank funded, and now we have the SUTREPS. Since I'm sure the time is running, that's why I have to move fast. So today I'm going to talk about SUTREPS. It's a 5-year project, and we are already in the 3rd year. And this is the funding agency is JICA, the Japan International Cooperation Agency. They are the lead funding agency, and also if you look at the agencies that are involved, we have 3 ministries, 4 departments from government of Bhutan, and we have 6 institutes, very renowned institutes from Japan, and they are helping us in its joint learning process. It's not like expert comes in, dictates something, and then they leave. Here we work in collaboration with them. Can you please? So this is the examination facility that we have built. Yes. It's very different because this facility cannot be like a residential or commercial houses. Here we have 2 reaction walls, and then we have a strong floor which is around 1.2 meters. I'm sure nobody attempted to build that heavy slab in Bhutan. And even the reaction wall is 1.2 meters. Now, reaction wall has to be very strong because when we do the rail size test, the wall has to resist all the forces. So this wall has been designed to carry at least 2,000 kilonewton at the height of 5 meters. It's 7 meters in. Let me skip this. So these are the different construction phases. Excavation, stone soling, PCC works are very common. But the interesting part here is we have a big MAC foundation, and we had to build 7 shear walls and an encapsulating shear wall to support the strong floor. And again, in the strong floor, we had to keep provisions very accurately, so for anchorage purpose. And then we have this reaction walls. Another interesting part of this facility is we now have a shaking table. People, we tend to, we don't know about our own neighborhood, and we know about the other neighborhood. So what I'm trying to do here is trying to create awareness. So now we have a facility, and also we have a shaking table installed in this facility. So if you, as of now, you can do 2 kinds of tests in this facility. One is dynamic shaking table system. Why dynamic shaking table system is very important is only through such kind of tests we tend to understand about the earthquake input and its response. And also what we can do is if you don't have the budget, you can always downsize the real structure 1/3 na bay, and then you can test. So we now have a dynamic shaking table. I'll show you a short clip. Please ignore the model. So this is the shaking table that's now available in Bhutan. And the weight that it can hold is 10 ton. 10 ton. And this is far more important, because let me share you how these IS codes are developed. Even for right now we use the StatRolo, ETABS, SAPS. Everything's inbuilt, but how did they get that data? It's all through this kind of test. So even for reinforced concrete, I'm sure they must have done this kind of full-scale static test. So here what we do is we built a rail-size structure. Rail-size structure. We already did the first test last year, where we built 3 structures, 2 rammed earth and 1 stone masonry with mud mortar. So we already did this test with the help of 4 jacks. So now we have 4 jacks. 2 jacks has the capacity to push up to 500 kilonewton, and another 2 to push at least 1000 kilonewton. But how to do this, it's yet another topic. So I'll not share the details, but we do have the facility to test this kind of structures. I'll just show you a short clip how the test is done. These are the 3 specimens we tested last year. So we have the 4 jacks, and it gradually pushed. Push pera loko nahi mein. And then we try to, but it has to be either displacement control. So we already have this pre-formulation, like how to do the test. Like let's put a drift of 1/500, then reduce that to 1/100, 1/75. So based on the deformation, we try to get the strength. And right now we have already analyzed some of the data. And although I cannot share with you the details, but our ramjet structures are quite strong now. And we do have small laboratory. We have Bhutan Standards Bureau laboratory, which is also a very interesting facility. And they have been our co-partner, like helping us. They don't say no to us. Whenever we go there and request, anytime they say yes, yes. So we do use the equipments. But the problem we faced was the equipments that were there in BSP, they only cater to concrete blocks level, because we have this compressive UGM machine mode. Here the compressive MPa can go up to 20 megapascal, 25 megapascal. But if you look into ramjet structures, it's highly, like, if possible, 2 megapascal at the highest. We didn't even achieve that. It's 1.5 to 1.8. 1 megapascal is good enough. But that's another topic for a day, different. But now, how to measure our load using the equipments that are here in Bhutan? So we have to buy load cells. We had to buy load cells which could actually measure up to, like, from 0 to 1 megapascal it can capture. And then not just the load, we need displacement. Those are the important factors in terms of analysis. To do the displacement, we had to buy displacement transducers. But now this has been upgraded with the help of JICA project. So we now have a displacement sensors, which are laser sensors, which can be used for very small tests as well as for large tests. And also, we have a very good data logging system. Those who are interested to do like miniature tests and have a very good results, these are the equipments. We didn't buy these equipments out of nowhere. We really had to think how to sustain. So we really had to consult our experts, and they are the ones who are providing us this help. Another interesting fact, we have a 3D laser scanner now. So with the help of 3D laser scanner, we can scan a building. It's very easy, just leveling then we just do the scanning. But the thing is, you need to know how to do data processing. So I need data processing. Otherwise, then you have to do the documentation, check the wall thickness, height, chamgi thickness, everything. But with this 3D laser scanner, it's made our job quite very easy. So these are the facilities that we now have in Bhutan. Now, having a lab is not enough. We have to think about way forward. So the lab is the basis for the small test, but now what we are trying to do is through experiments that we are doing, we want to get guidelines, that's for sure. We also want to institute research institute for traditional structures. I'm saying this because, like, anywhere in the world except for a few countries in Europe or Eurocode 6 times, we do have data. Even in Japan, extensive data. But now we cannot say we don't have data, because we have data. So now with that, we want to upgrade to research institute. We have already been blessed by His Majesty, and then we have these mission statements and everything ready. But the more important thing is we need collaboration. Where now here it's CDCL. I think it's one of the important organization level. And when you go, people, I like to learn, I like to read, and I like to do research. So for me, CST would be more important and relevant. And then other things like RUB, and then we have foreign institutes, because institutes from Switzerland, they are also interested to work with us. So there are people around the world, they are experts, they are professionals. It's just that Machinagi, young professionals too, and we really need to work hard. That's the end of my presentation. Thank you.
Thank you, Pema. I think you're the first to come within time. I think. Thank you so much for your time management. It's very important. He has talked about the traditional building and how we do the testing. But one thing good to know is that we do have data now. Data has to be now put into practical. We have to learn on these data. And as you rightly said, the institute, the CST, where a lot of researches has been done. I think since all research can be based on data, as long as we have the data, things can be carried forward now. Thank you, Pema, so much. Now, can we go up to the last presenter? Mr. Tandin Duji, he will be talking us on the bridges. Till now, I think we have been talking about tunnels and we are talking about buildings. Now, I think we will come to bridge. Bridge is one area where, honestly, Bhutan still needs to develop. Our capacity in bridge construction is very minimum. We can do roads now. Our citizen tunneling also. I think bridge is one area where we need to really focus. So my speaker, if you can come to the dais now. Okay, Tanti, the floor is yours.
Distinguished guests, ladies and gentlemen, a very good afternoon. Since I'm the last presenter, I could understand that all of you are tired. I'll try my best to be brief and concise as possible. Ladies and gentlemen, my topic of presentation is technical approaches adopted in the construction of first network arch bridge in Bhutan. The purpose of this paper is focused to our young engineers so that in future when they have to construct bridge, at least they could refer this document and know how the bridge is constructed. And at least you could see the challenges, the processes in the construction so that at least you are not new to this. So this will at least guide you. In my presentation, I may not be able to explain everything, but if you are interested, you can refer to the details in the book. The presentation outline comprises of brief introduction, a brief concept, construction stages, and a bit of materials and expenditures that is gone into the construction of these bridges, and then the recommendations. This bridge, which was constructed by CDCL, it is located, you can see, in Samduzongkha. You can see the Samduzongkha is in the southeastern part of the Bhutan, and there is a river which is going, and that is called Bungsamchu. And the purpose of this is, as per the municipal, the 11th five-year plan, they want, as a part of their expansion plan, this bridge needs to be constructed. The design was done by a JV firm from Bhutan and Bangladesh, and during the construction, the municipal authority has already entrusted CDCL to review the design. Coming to the design concepts, this concept of network arch bridge was originally developed by a Norwegian professor, Pierre Trevitt, in 1950s. And the concept is very simple. If you see this, the deck which is suspended from the elevated arc, and it is elevated through a network of cable hangers intersecting and interconnecting at a defined inclinations. And this acts as a truss, and at the same time, you know, the arc which is under compression is susceptible to buckling. So that is also taken care through providing a wind bracing. And during this design, the relevant design standards and criteria were followed, particularly Indian Road Congress and IS codes. And of course, during the design, the MEDA Civil software 2011 was used, and when the CDCL reviewed, we reviewed through 2016 software. And of course, it also the criteria that we have to was considered is based on Department of Road Bhutan 2015 General Specification for bridges. Coming to the construction stages, as you all know, the first is the abutment construction, which forms the substructural component, which actually supports the bridge at the end and also connects the approach road. So during the construction, around 8,250 cubic meter of volume of earthwork has to be excavated, and we have actually semi-mechanized system were used during the construction, and after the abutment has been constructed, then of course the bearing is placed. In the second stage, which is very important, the temporary support, because having constructed the substructure, then you need to construct the superstructure. And in most of the construction, which actually we have seen is much of importance was not given to the temporary supports, and particularly in bridges and all the structures. This is very important, the temporary supports. Actually, we have to design it and really see actually, otherwise there will be a catastrophic during the construction. So what we did was, using the software, the support structure, that the intermediate supports that to be provided was, stimulated to the practical scenario. So 4 conditions were analyzed. The condition 1 is deflection of main girder without the intermediate support. So you can see that the deflection was so high that without this, and even with the stressing of the main beams, even with either 3 or 6 cables, that is not helping. And why we need to consider is because the bridge is constructed. We are constructing over a river. So anytime during the flash flood, this support might wash away. So we have to consider that situation. The condition 2, deflection of main gutter with 2 intermediate supports. The first one is without, and the second one is with 2 intermediate support. We are actually analyzing what is the situation. So what we found is somewhat that it is acceptable, but without the superimposed load, because having constructed the deck, we have to again provide a construction equipment and props for the arches. So it is not able to take up that load. And third, we also checked the support reaction and member stress when all 4 temporary supports are functional. So we found that in terms of the, with the 4 temporary support, in terms of the stresses in the concrete and tensile, were within the acceptable, allowable compressive stress. So that is perfectly safe. But safe in the sense, during the construction, anytime a situation might arise that the flash flood might wash away some of the support. So what we need to consider is, at any time, the 2 support has to be there, intermediate support. But even with the 4 support, what happens is, if that flash flood comes, we have to immediately, because there will be abrupt increase in the stress, so where we have to immediately reduce the load of the superimposed load. So based on this, a temporary support, 4 intermediate support at 10 meter intervals were provided. Now the rest are the third stage. Then we have placement of reinforcement, embedment of hanger anchorage inside the main gutter, profiling of the cable ducts, and then concrete. And then after having done that main gutter, then we focus on river formwork and concreting of cross gutter and deck slabs, which are the normal process. And in the main gutter, there were actually 6 tendons each on the main gutter to be done post-tension. So the process involves where tendon installation, the stressing and grouting. So theoretically, we have to do 50% of it. But since we are, after 14 days, in case if there is a flood, but luckily that didn't happen, and then we did it after 28 days. Then, having done this, then you can also look at the picture. Then we have to place the prop to support the main arch gutter, and there again the rebar arrangement, and also along with we have to carry out the wind bracing side by side, and then embedment of anchorage set in the arch at the designated location as per the design, and then we can do a segmental concreting. The third is the placing of cable hanger. So there we have 3 components. One is the cable hanger and connector, and the anchorage assembly. The assembly consists of base plate, tie rod and stiffener. We bought this cable hanger which is a spiral strained low relaxation grade of 1570 megapascal from Usha Martin, and then N connector also from Usha Martin, and anchorage set from TD Udok, Kolkata. Total weight around 37 metric ton, which was all considered in the design. And these are some of the pictures you can see. So N connector, the I connector, and then base plate and the cable hangers. Coming to the material and the major expenditure, mostly are other than the cable hangers, most of these are sand, cement, timber, these are local materials. And then coming to the expenditure, the 48% the cost went into material, and 30% to equipment, 22% to equipment, and 30% manpower, the labor cost. Some of the recommendations after having constructed and then reviewed this design, we found that the cable hanger design similar to the design which was already done at Ria Bazar Network Arch Bridge in Bangladesh. What they have used is they have used a normal TMT rebar 28 mm diameter, 3 numbers, encased in a non-corrosive stainless steel pipe and then grouted with the concrete. Actually, this is found easier and we can easily do it in Bhutan because of the materials that are available. Since the design was of cable network, we had to go out of Bhutan to really again find the manufacturer and then customize the design to suit. So that took actually most of our time. The second recommendation, using self-compacting concrete. So literature says in Japan and Europe, this SCC was used in bridge, building and tunnels from early 90s. And it has high performance, better durability, and maintains the uniformity, and also as well as in the component which has a heavy reinforcement and where it is subjected to high segregation of concrete. This is better. And in CDCL, in the construction of other bridges, we have used this and the result is actually quite encouraging and good. But we haven't used a network, but we actually in future, if we take up, we would like to recommend this because there, particularly in the network, it is at a high height and there are heavy reinforcements. Coming to cost and time overrun, because the project duration was of 18 months and we took actually 21 months, and it is not because of the actually delay by the contractor, but the circumstances which are beyond the control of both the client and the contractor. So mainly because of relocating the utility lines, change in design of the cable, and seasonal rain and flood. And in our actually, this has already cost our overhead cost to the project. But as per our government procurement norms, this is not compensated. Of course, time is given, but not compensated in terms of the cost. So the risks of time loss leading to overhead costs actually should be included when actually we either bid or we actually put the cost for the future bridges. And of course, in the process, we have already done this soil test. Before we started, we excavated and we tested the soil. We actually checked and correlated with the design and then found actually, and this is very important because you never know. Because at the time of design, it was just the surface actually, geotechnical investigation actually. But once you excavate the foundation and then you actually know the real soil structure. So we found this soil test is very important actually, and then checked with the design. And of course, please don't ignore the staging design. This has to be really done, checked. These are some of my reference, and I have to say thank you. And before thank you, today I would like to really take this opportunity to thank two of the persons actually who has really influenced particularly me and my colleagues in this profession. And they are, I have my gratitude, respect, and they are my role models. And thank you very much, who have really shaped my life and my colleagues' life in this professional field. And they are Mr. Prince Ogese, the CEO of CDCL, who is right here, and Mr. Didi Sharma, who is also right here, Siri Didi Sharma, Chairman T2S Infrastructure, who is right here. And I have been, we are associated from 2011, and even till this, every month, he used to call me and advise me on this professional in the field of bridge construction. So today I take this opportunity because there's some time. So thank you very much. These two who are role model. Thank you.
Thank you so much for your humbleness. I think, as I was saying, the bridges are one of the areas where we really need to focus, where we really need to develop capacity. This network bridge is just one type of bridge. There are many types of bridge depending upon site situation, depending upon the length of the river, depending upon the aesthetic requirement. There can be various types of bridges that can be developed. I think in Bhutan, I think we have mastered only one or two types of bridges. So this can be kept in mind, especially for the college students, where we have to do some research. Bridge is very least explored study in Bhutan. So there is a lot of future in the bridge area, please. With this one, I think, can I open the floor for question, answers, comments, views, anything that you may add to us, these dynamic speakers here? The floor is yours, please. Yes, gentleman there, please.
Hello. Firstly, to introduce myself, my name is Karchung. I'm ex-employee of PHP2 and currently undergoing undergraduate in Civil Engineering College of Science and Technology. My question is to Sir Pema regarding the ram earth construction. Now it's good that our country is coming up with a facility to test our structure. So in Sir's presentation, I came through the shaking table test. So what is the permissible magnitude of force that we can apply to that plate shaking table test, and being the Bhutan as in earthquake prone area, as per the Indian seismic classification, Bhutan lies in zone 5. So if earthquake strike in Bhutan, so what magnitude of the earthquake that the structure can withstand if the model of the structure pass through this plate shaking table test? And second question is keeping in mind with the serviceability and economical in construction in the engineering phase. So engineering in construction phase, there's always an option. So if one is expensive, and there should be alternate and which is economical in construction. So sir, as a researcher and as an engineer, how would you recommend our locality, especially those who are currently undergoing with the conventional construction trends? So is there any improvement in construction trend in earth frame structure? So if there's any, if sir could suggest. And second question to the first presenter. So CTCL, yes, I do believe CTCL now it's one of the most emerging construction company and highly regarded in terms of human capacity and labor capacity and construction quality. It's really a high standard. So on behalf of all, I would like to thank CTCL. So taking and keeping making the Bhutan pride. With this, sir presented that electrical installation in the phase of construction. So CTCL as being a competent company. So is there any next stage, for example, installation of main hydroelectric package, so auto mechanical package? So in our country just now, all these hydropower installations, main package installation are done by BEL. So as being a CTCL, one of the renowned construction company in Bhutan, is there any future plans to take over this auto electric installations? Thank you.
Thank you, sir. Both the questions are very intriguing, as well as the first question is quite straightforward, but the second question can be tricky. Regarding the shaking table, in terms of shaking table, we have just installed it and then did the first simulation. Just for information, we have already built 4 specimens which are reduced from the original size, and we are going to test that in the month of October. So if you're interested to see how traditional structures behave, it will be a pleasure to invite you. And regarding the shaking table, we have 2 methods of test here. Analu, what you need to know is, first is, for the shaking table that we have, the dimension is 3 by 3 meters, 3 by 3 meters. And the stroke length, when it pushes, stroke length is 150 mm plus minus. And then the PGA, that's more important with the one. It's 0.5 G and the weight limitation is 10 ton. So within these limitations, we have to do the test. And another thing is, this is a unidirectional shaking table. Earthquake it's all over the place, not up and down, but it's horizontal, both X and Z direction. But here, due to the cost, we could just afford unidirectional. That's why we have to build 2 specimens, put it in 2 different parts, chi long direction, chi short direction, and test it together. Documentation is important. And the first kind of testing. Or the second thing is, what you can do is, if you have data, because we are working with Japanese institutes and professors, I'm sure we'll get the Tohoku earthquake data. And so already these are all there in the data, especially with seismologists and agencies who looks after that. We just need to get their data. We need to get their data and then put that data into the shaking system, shaking table, the control panel, and then replicating it. So this is how you do the shaking table test. I'm also very new to this subject. I will have personal experience only in October. And regarding suggestion for improved rammed earth construction, let me share with you that rammed earth or stone masonry, it's very important that if you see the board of notice saying the seminar, they put some rammed earth and stone masonry structures, which shows that deep within your heart you have care for your traditional structures. I want to build steel structures and reinforce it. But there are improved versions on how to improve the strengthening measures. First thing for rammed earth, it's monolithic construction. It's always in block form. So what you need to do is put wedges. Our indigenous knowledge system is very strong. Our forefathers, our craftsmen, they already know those techniques. But within last 10 to 20 years, people were more into economy. But they want to build house in 2 months. Where in earlier times, rammed earth takes ages. So compaction is also a problem. So compaction goes to the legitimate connections legitimate. If the corner key and bonds to legitimate the version, these are the simple interventions, and I can prove that because we did test pull down test and how those small interventions can actually improve the strength. Anidhi, we already have data, and if you're really interested, please visit us. I will share with you all the details. And another thing, now we have built another rammed earth structure, but it's with improved version with vertical reinforcement and concrete bands and everything. How this will behave, right now it's too early to say. Please join us for the full-scale static test in the month of October as well as in December, where you will really see for yourself how our traditional structures behave. Thank you so much.
Regarding the involvement in installation of electromechanical parts in hydropower construction. So currently CTCL has just started building capacity in tunnel construction, and definitely in the near future we have a plan to participate in underground construction like powerhouse and transformer cabins and so on. So definitely we have a plan to get venture into installation of these electromechanical parts in the powerhouse and other parts of underground construction.
I thought I will just add on to what Tinley had mentioned, more pertinent to what our colleague behind asks. I think he was asking if we can develop capacity in the hydromechanical and electromechanical. I would like to say that we are right on track, and I think there is a consolidated effort in that area, because I think there's a huge potential in the hydropower market. And if you look there, by consolidated, what I mean is that DGPC on its own through its subsidiary company has already started state-of-art BHSL Imola, Bhutan Hydropower Service Limited in Gyelephu. And if you go there, you'll find that they will do all this. Even I think electromechanical also might come later, but that'll come later. But I think they are more into hydromechanical turners, runners and turbines and all that, which was not there earlier. And if you look back the days of Chukha and even up to Tala, when we had to repair our gates and then turbines, it used to be taken to Nepal, and then it used to cost us millions of dollars. Now it is right here, and I think they have collaborated with one of the best European company, Andritz. Alstom. So they have
Alstom is taken over by GE now.
GE. So you can just understand. So GE also have a subsidiary in India. That's one. The other one, the recently coming up is I think Bhutan Automation, Mola. So some of the things that you are asking, these are already in shape, and perhaps by the time you think of taking new job ventures or whatever, perhaps these are the areas, Seshuni, and these are real high-tech areas. So I thought I have answered your question.
No, sir. To supplement CEO, sir, I think now CDCL is basically into civil construction. They are into tunneling, and dam and powers. But when you talk about electromechanical, there has to be a manufacturer, not any contractor, but a manufacturer, OEM. We call it original equipment manufacturer. Now, lot has to be done with financing. Now, Chukha, Tala, Kurichu, you see, now Mandechu, funding has come from India. So funding always comes with a string. Takachu funding is from OEKB, Austrian government. Bidding was done in Austria only. So only Austrian companies were eligible. Now when the funding is from India, only Indian companies are eligible. So with the money, there is always a string. That's why in India, till Punan Kanchuki time now, there were only BHL who had the reputation of manufacturing. Though now India, we have got Andritz, we have got GE, we have got White. They do not have the requisite experience, because eligibility, we always say you should have supplied at least an equipment for 2 projects which are commissioned and running successfully for 2 years. So these criteria did not allow Andritz, GE and White to participate in Mandechu or in another. Now come Kholongchu. Kholongchu funding is again only the DGP's business part of equity is being granted as a grant from India, but the loan is from the market. So Kholongchu we may go for ICB, International Committee bidding. There we cannot say who will come. So I think CDCL to go into E&M equipment may be I think just now can we say that as a wish list only. We have developed. Now DGPC, as I was saying, we have subsidiaries. We have JVs with initially Alstom. Alstom has been taken over by GE now. We have a service center established in 2014. Since last year, we have started manufacturing also. BHSL has manufactured 2 Francis turbines. Now starting this year, we have given order to manufacture Pelton runners also, very complicated runner. And by the end of this year, we may give runners for Tala also. So I think we have to take small steps in going into it, because these are really sophisticated precision. While DGPC, we have been into O&M for around 30 years now. We claim we are experts in operation maintenance, but we still lack design and engineering capacity. We need to focus on design. For that, we have established Duke Green Consultancy, DGC. So this DGC is building capacity in design and engineering. Once this is done, then DGPC can become, we call it water to wire capacity, in-house capacity. We have O&M only. We can do some PFR, we can do DPRs also, but we don't have design and engineering capacity. Now, as I was saying, we also had tied up with Andritz Hydro, this Austrian company. We have set up Bhutan Automation Limited into SCADA, into protection, into mechanized type UV. So we are taking our step in a small way, which can be sustained. We will not fall back once we attain that capacity. So as far as O&M is electromechanical equipment is concerned, we have tied up our partners. Slowly over a period of time we will build capacity. Now next question, a sincere request. Question has to be not more than 2 minutes, please. Please do not explain your question so that you give more time for the speakers to answer. There are two, I got two. So Madam Jimmy, you have to moderate me. Unless you say stop, I'll keep on asking. Please, thank you.
My question is to the GM of CTCL, technical officers, and my question is, why arc bridge? Why not rectangular or hexagonal or triangular?
Thank you very much. Yes, you are right. We can have so many designs actually, but we also have to assess how it blends with the environment, with the site situation. So if it is in a very deep gorge or maybe in a plain, the different designs will go, because you cannot say I want this design to be in this place, because it will be purely governed by the site situation, and of course the cost benefit and those will come into picture. But this particular bridge, we have no option, because this was what our client, which is Samsung Thomde, they want actually. So that's why as a actually contractor or executing agency, we have to go by what the client desires. So this is, but actually there are different ways to assess what type of actually design you want. I mean the choices, the assessment can be done. Thank you.
As I was saying, no, I think this is just one type of bridges. There are multiple types of bridges to what, as you rightly say, square, triangle, arc. But as you were saying, I mean, mostly it has to be do with the, I think, as far as know, the length of the bridge span, the aesthetic, the soil foundation. There are many factors that need to be considered. One is, of course, aesthetic point of view also. Okay, now I think we have one last question, because we are supposed to finish at 5:45. We are already touching 6. The gentleman here.
Thank you.
Please.
My question is to Mr. Pemala. After the traditional Bhutanese house with the ram earth and then a timber structure, once the tastes are found okay, will it be brought to Thomde, or will it be kept for the rural areas? Thank you.
Thank you. The test that we are doing is because I think main is because we don't know what how the structural behavior of our own structures are, but whether to bring it to urban or whether to bring it to rural, that depends on the community. For especially in rural areas, they still have this community vitality. They help each other build. But let me share you a very interesting. It's not a story. It's like a fact. Now, ram-built structures in the Western world are becoming a house of bridge. So, example, the second example, those things are considered to be food for poor, but now those things are served for the rich people. So, dynamism change. Whether you want to build it in urban or rural, that depends on the municipality, owner's perspective. But in Ngachigidi, we just want to conserve and preserve our own traditional structures. And also, when we talk about test facility, now I think everybody is thinking that it's just for traditional structure. These equipments can be used to test any kind of structures. It's just that you have to customize and then test. So it's multi-purpose. But for now, we are seeing traditional structures because it was developed for traditional structures. Thank you so much.
Okay, no, can I take a... Yeah? Yes, please, sir, please.
I would like to request the chair just a few lines now. I think I'm really impressed, and I think I would like to commend the effort made by PEMA at the Department of Culture. I think this is what we want. And if you look at this afternoon session where we talk about intelligent urbanism, some of the thought-provoking technologies related with wood structures, I think these are coming completely out of the box, Mewala. And this is exactly what this seminar would like to stimulate. And in fact, we have among us representatives from the international organization, government policy makers, and some of the key movers and shakers who actually put up the proposal to the decision maker. This is something we would like to come out with, well, instead of going around in that vicious circle. And the reason I'm saying this is I think this afternoon when Gile and our earlier moderator, Mr. Funso, the DG of Narcotics mentioned, I think this is something we really need to look at because we are in a very pristine Himalayan region and we are slowly getting outboxed by concrete structures all around. So these are some of the real solutions. My sincere hope is that I think this would not just die away with that load shaking test system that you have, but I think you should go further. Right now I think the collaboration is there with the Department of Disaster and Department of Culture. But one other point I would like to point out is I think at the government level, at the national level, we are really toying with the idea that we should really protect our heritage, that is the traditional structure. But up until now, like he mentioned very clearly, we have the zoos, the artisans. There is no documentation, and I think they have done these wonderful zones. This is the right opportunity. If you look at Thimphu structure plant, urban plant, I also worked as a mayor down there. I realized the challenges. On one hand, we want to promote traditional structure, but there is no sufficient apparent evidences to convince people that this is the way we should go. But now I think these things are coming up. If tomorrow, 15, 20 years down the line, even right now, this morning when you came to this conference, perhaps you must have faced the traffic congestion all the way from Olaka, half an hour every morning. So these are kind of things we are now dealing with, and I think this is a step in the right direction. If you look at some of our regional centers like Bontang, it still remains unpolluted. Tashiangsi still remains unpolluted. I would say, the traditional structures are fully in Bontang. That is the way we want to go. And I think right now you are talking about the seismic implication and purely from earthquake point of view. But here we have a big opportunity, to showcase that traditional structures can be built for a common habitat. And I think this is the way to go for a Bhutanese. And my sincere thinking on this is that I think probably the Department of Culture should take the lead in actually convincing the Tromdes. And then I think perhaps even if you want to collaborate with CDCL, we are committed in terms of research. We do collaboration with CEST. I think you can bring, you have tied up with some of the best universities in Japan to do this researches. We are there, CDCL is all there. And I think these are some of the areas we should really see. And in fact, through seminars like this, I would like to see researches, not rocket science researches, applied researches, which will solve the problems that we have in the industry. So this is what I thought. Thank you.
So thank you so much for your wisdom and your kind advice. I think we will keep this in mind. With this one, I think, can we call it off a day? Thank you so much. Especially on my own behalf, personally, I would like to thank CDCL and the organizer for giving me this opportunity. I'm really privileged. And I also thank the 4 speakers, very dynamic and very active speakers. I'm sure you will keep up with the research. There are a lot of inputs that we have received from you, and it will go a long way in shaping our future Bhutan. Thank you so much. Thank you so much. Have a nice day tomorrow again.
This brings us to end of today's session. We are so glad to see all the seats still filled up just as it was in the morning. Thank you everyone for being with us throughout the day. Thank you so much for your patience. We hope to see you all tomorrow at 9 a.m. sharp. And just for the information, we have also arranged closing dinner for all of us tomorrow. And please make sure don't miss it. Even if you have missed few sessions today, make sure that you don't miss tomorrow's closing dinner because we have built up many other entertaining programs for you all. Thank you.